We watched the video.
We factored quadratic so far, right? Yes, we have. So we factored things, and I'll just do an easy one. Tell me how you factor that. Walk me through all the steps, not the shortcut on this one.
Okay. 3 times 2 equals. If you add the
Yes, what multiplies to 6 but adds to 5? 3 and 2. So I have x squared plus 3x plus 2x plus 6. And then I said, oh, slash it down the middle. Yep. I forgot. Okay. What? Okay, that was quite extreme. What can I factor out of the first two?
X.
X. What's left? What'd you say, Wills?
X
That's going to be on the video.
You take out of the second two. 2. X plus 3. And so then I take the x plus 3. This method is called, do you remember what I told you it's called?
It's cool.
Factoring by, did I tell, grouping. It's a grouping method. Good job, good job. So we can also factor some polynomials by grouping that may not be necessarily a quadratic. Okay? Or actually, let me show you quadratic form first. Quadratic form means, this is why this is not my favorite section. It's kind of here, there, and yonder. Quadratic form means there's 3 terms. 3 terms. The first...
Wasn't it called trijet?
What? That's trinomial. Quadratics can be trinomials. They don't have to be that. All right, the first exponent is an even number. So maybe, I don't want to make it too hard. 3x to the 4th. The middle number has to be half of the first. The middle exponent is half of the first. If those are true, then you can group it.
So if you had like
So
3x2 x1.
Yes, but that's quadratic.
Wait,
But like if this was 6 and this was 3, and the last one's got to be a constant. I should put that last constant. So it looks a lot like a quadratic. It's just not 2, 1 constant. It's even half constant. Does that make sense so far? So when you group it, 3 times 24 is somebody. No variable. What multiplies to negative 72 but adds to negative 1? Y'all should be able to get that. Yes, and?
9.
Yes. So it's 3x to the 4th minus 9x squared plus 8x squared minus 24. You see what we did? Same thing we were doing when it was quadratics, only we're rewriting with squareds instead of just x's. Does that make sense so far? Okay, where? What? It's 3 times negative 24.
It's just like that.
Yeah, it's the same thing. It's factoring. It's still factoring. Same method. Now slash it.
Slash that thing.
That's right.
Slash that thing.
What can you take out of the first two? 3x squared. What's left?
X squared minus 3.
Good job. Middle sign. What can you take? You can take 4 from that.
You can take
Oh, you can take 8 from that. Sorry. What's left?
X squared minus 3.
Yeah, minus. So now it's x squared minus 3 times 3x squared plus 8. Does that make sense to you? It's nothing new. The only new thing are the exponents. Everybody good so far? There's like 4 different patterns I have to show you. That was one. You want me to do one more of those? Or are you good? Okay. So one other thing that you have to think about, ooh, no orange with that purple, is you have to look.
That's another thing that I laughed at. Yes,
All right, so you have to look at the pieces when you're done at this point. And you have to say, can you factor any pieces any further? If you can, you have to go ahead, because what we're doing is we're factoring completely, okay? Which means we look at the pieces that we've already factored and we say, hey, can I factor it any more? Can I do it again? Are there any more patterns? In this case, no. But we want to make sure from this point forward that we do factor completely, since we're talking about polynomials and not necessarily just quadratics. And you'll see what that means in just a
There was one
minute.
problem on the homework where if you needed to factor it down even more.
Yeah? Let's say I had that. What's the pattern? It's difference of two squares, right? Because the definition of a perfect square means that you can multiply something by itself. What?
What's this 3?
What?
You just said the difference of 2 squared.
Yeah.
So, 81 squared is 9, and 9 squared is 3.
We're gonna do it twice, but you got to go step by step. So you got to do the 9 first. So you're right. So how does this factor?
X squared minus 9.
That's right.
X squared plus 9.
And so what we're doing is we factor completely is we're going, okay, can either one of these be factored again? Yes. Only the first one though, right? Second one can't. It's a difference of two squares, not a sum of two squares. Right?
Because
This one can be factored as x minus 3, x plus 3. Because it's a difference of two squares. But this one, it stays because it's a plus. To meet the requirements of that pattern, it has to be a difference of two squares. Does that make sense? Yeah.
So is writing notes,
Yeah.
examples.
Yeah.
I just put it higher.
Okay, so we factored it down. You recognize that this is a difference of two squares. Because x squared times x squared is x to the 4th, right? And 9 times 9 is 81. Because there's a minus in the middle, it's a difference of two squares. So I break it down, x squared minus 9, x squared plus 9. Then I look at the factored pieces and I say, okay, this one is a difference of two squares again. So I break that one down here. But this is not a difference of two squares, it's a sum, so it doesn't break down any further. Now it's factored completely. Okay, so factoring completely, look at the pieces, make sure you can't factor any further. Everybody okay?
Yes.
Ready for some patterns? No, that wasn't
Wait,
a...
that wasn't one?
That's still kind of, that's just factoring completely.
That's rookie math.
That's, yeah.
Yeah.
All right. Grouping. You've already grouped. That's how we factor. It's a nice thing about learning that technique to factor quadratics because it works when we get to this. If you see something like it's not quadratic form, it's not a quadratic, it has 4 pieces. But what I want to do is I want to look at it, and since it has 4 pieces, that clues me in and, hey, maybe I can slash it and factor it, right? So let's see. If you were to slash it, what can you take out of the first 2? X squared. And what's left?
X minus 3.
Middle sign. And because it's minus, remember that's going to change the last sign. What can you take out of this last 2? 16. What's left?
X minus 3.
Look at there. How do you know it groups?
Because you're 2 in the parentheses.
Look at the common factor here, the x minus 3. So I have x minus 3, and then what's left is x squared minus 16.
And you can turn that.
You absolutely can. Good job, Corbin. It's a difference of 2 squares. Okay. X minus 3 I can't break down any farther, so I leave that. But the x squared minus 16,
X minus 4, X plus 4.
Now it's factored completely. Good job, y'all. I'm so
So
proud.
you only go ahead and easily learn this.
If you see 4 pieces, that clues you in that it's probably going to be a... Yeah.
Is there going to be any situation where there's 4 pieces where you don't need them?
It may not do it. If it doesn't do it, then you don't. But for our sake, yeah.
Are those,
It'll do it.
do you, wait, so how do you know to factor it more is if it's a perfect square? Because
You
the
look
one
at-
above was like 9. So that's
Yeah,
a perfect square,
right.
16 perfect square.
Yeah.
So if it was 20, like 7 or something like that.
Yeah, it wouldn't. Now, 27 is a perfect cube, and we're fixing to learn about those, so it might factor then, but
Anything multiplied by 3.
for right now in your life, yes. In 5 minutes, no.
Cube of 77.
3 times 3.
Yeah.
29.
Okay, yes, that's perfect. Then no, it would not break down any further. Questions, comments, or concerns about grouping? So now you have factoring completely, you have quadratic form, and you have grouping. Is everybody okay on those 3 things? Yes, no, maybe so, yes? Okay. My favorite
Before we use those, I'm going to say
pattern.
something loud that is not going to be in the video. I'm going to say it in an unexpected place.
I'm not very good at editing either, so I'd probably have to just delete the video and record 4th blocks. The world may never know. What?
Do you just not record? Wait, so do they listen to?
All right. Here's where, thank you. I think you got it that time. Here's where it gets confusing, and this is why. You can only have a difference of 2 squares, right? Yes, say yes, because that's right. Yes. Okay.
Yes.
But when we talk about cubes, you can have a sum or difference of 2 cubes. Oh.
Wait, that's
Dun,
so
dun,
cool.
dun. Okay,
Not
so, what?
Oh, yeah.
All right, so let's think, it does make sense. Why does it make sense?
Because, I mean, you said we could have a sum or difference. So, I mean, if you're adding, then you have a sum. But
Right.
You a sum. If you're subtracting,
But as far as multiplication and division, why might I be able to have both signs with a cube?
Pieces instead of 2.
Because you have more than 2 pieces. Wait, are you gonna?
Think about this, think about
If you have
this.
some, you can have like.
What is 5 squared?
25.
What is negative 5 squared?
25.
What's 5 to the third?
Negative.
125. What's negative 5 to the third?
Negative.
Negative
Yeah.
125.
What?
I can do something negative to the third and
So
get a different
negative
answer.
5 times negative 5 is what?
Yeah.
25 times negative 5.
Okay, so before I show you these patterns, let's talk about cubes for just a minute, okay? Cubes are powers of 3. So, 2 to the third is?
8.
Yes. 3 to the third.
27.
Good job. 4 to the third. Let's see how.
400.
Whoa!
Whoa.
No cigar.
5 to the third.
1.
We're taking numbers to like 5 times 5 times 5 is 125.
6.
We're gonna have to be able to recognize those. Somebody said it.
234. Is it actually? Oh, I thought I was just saying over there.
You had to remember this in Galloway class?
No,
It's first grade.
Yeah, write them down because you're probably not as familiar with cubes as you are perfect squares. You will be, but just when you see these numbers, just like when you see perfect squares, the first thing you think is, hey, that's a perfect square. So when you see these numbers, the first thing you think is, hey, that's a perfect cube.
Is there such thing as a
Actually, yes. That will be chapter 3. There are not just cube roots, but 4th roots and 5th roots and any other roots you want to take. Yes.
I thought I made that up.
We call them nth roots because you can put any number in for n and take the root of it. All right. Why is it not recording? I'm going to give it to you in variable form first, then I'm going to come back and do an example for you for each one, okay? I'm going to give them to you at the same time because the pattern is the same for both. Sum of two cubes would be both numbers are perfect cubes. With a plus sign in the middle, difference of two cubes, both numbers are perfect cubes with a subtraction sign. So just like when it's difference of two squares, it's two pieces, there's that special pattern. There's a special pattern here too. Again, you just really have to memorize this pattern. That's the only way I know to tell you to do it. All right, when you factor it, these are two different, by the way.
Wait, is this the pattern right here? That's the pattern?
That's what you start with. I'm showing you how it factors. You know how you start with like a squared minus b squared, and you'd have a minus b, a plus b, difference of two squares. All right, here's what you do. You set your signs up. You have a little parenthesis and a big parenthesis. Joseph, keep your hands to yourself. All right, and we're going to set the signs up in them first. The signs are going to be same. You're very close. Same, change, plus. Always a plus on the end. Same, change, plus. Okay, so if you're same, change, plus, tell me what the signs are going to be on the bottom one. Minus, plus, plus. Okay, now we need to fill in the blanks. We have a binomial, which is two pieces, times a trinomial, which is three pieces. Okay.
Trinomial.
For the first one, we do A and we do B. Okay, so if this number was 8, then the B would be what? 2. Because 2 to the third is 8. Okay, now we're going to use these two numbers to fill in the rest. Y'all ready? Yes. But we're going to do it anyway. Take the first one and square it. Take the second one and square it for the last space. And in the middle, we multiply them together. How'd you know that? So this is going to be the same. A, B, we square the first, we square the last, and we put them together here. Riddle me this. No, I'm just kidding. Okay.
Riddle me that time.
Look at that. That looks dangerously close to something you are very familiar with.
A squared minus 8 plus.
Okay, keep going.
Vertex form.
Quadratic trinomial.
Yes, you're exactly right. Perfect square trinomial. There's one thing missing from it, though.
The x. First plus.
The middle term.
What about the middle term is
It's
wrong?
not
It's not
going to divide. It would be.
It's not doubled in the middle. If that was 2AB in the middle, it would be a perfect square trinomial. But it's just AB, so that will never factor down any further for you. Okay, good. Now let me show you a couple examples.
Show me something.
I was there. Great.
Let's say I have, oh my gosh. 16x to the 5th
Nice.
minus 250, actually let's do plus, 250x to the 2nd. And I said factor completely.
I love
So my first step of factoring is always what? Your GCF. If there's a GCF, take it out. My goodness, take it out, sweetheart.
8x squared.
You can take out x. All right. Oh yeah, you.
No, 16 goes into 250.
Doesn't it?
10 times.
Take out x squared.
We know we can take out an x squared. What else are they divisible by? I know they're both even.
Hey, what
2.
about this going?
Okay, so let's take out 2x squared. And what's left in parentheses when I do that?
8x third, or cubed.
Third.
125.
I see something, I see something, I see
I
something.
see a perfect cube.
I see two perfect cubes. Does everyone else see that?
This is
You set that
perfect
bang
cube.
up, you know what I'm saying?
All right, let's set it up. All right, now look, the GCF is going to follow it down as we go. Okay, so it goes on the outside. I need a little parenthesis and a big parenthesis. What signs are going inside those parentheses? Plus.
Minus. Plus.
What times itself 3 times gives you 8x cubed? 2x. What times itself 3 times gives you 125? 5. First spot is the first one squared. So what goes in the first spot? Close. 4x squared. Good job, Kiana. You got to square both of them. Now square the whole thing. What goes in the last one?
10x.
25.
Oh, and the last one.
But the middle one, you are right, is 10x because I multiply them together. This,
Wait, multiply the what? Those things?
the middle two, yeah.
And that's your answer.
That is factored completely.
Okay, wait, so what you're saying is for the first one, you square that, the first one, then for the last one, you square that second one.
Yes.
All right.
One would think we were done though, right?
Absolutely not. We still have to factor that.
We'd be done if you
That,
stop. Can't even, oh, you've got the Where does it
The 10 came from these two multiplied together, Palmer.
Miss McGee.
All right,
Miss McGee.
yeah.
Seriously.
I show you how to factor because part of factoring is getting it so that we can solve.
Yeah.
Okay? So again, I'm back to making it equal 0. This is not a quadratic though. 4x, absolutely, Silas. 4x. When you take the 4x out, what is left?
4x to, or x to the
X to the 4th.
minus 10x to second
Keep going.
Plus 9.
plus
9.
plus 9 equals 0.
What about what's in those parentheses? What's it look like to?
That is
They're
a-
perfect squares. Does it? But it doesn't square dance.
You do 10 of 1.
What is it?
Close.
Cannot be factored.
You do.
Divide by a fraction.
This is quadratic form, huh?
You can group them.
You can group them. You can. It's quadratic
I
form.
said Chris.
So look, what multiplies to 9 but adds to negative 10? 1 and 9.
1 and 9.
Negative 1 and negative 9.
9.
But it's got to be x squared because that's the middle term.
Oh, so you just like factor like that.
Factor it like normal. And I knew that because 3 pieces, even, half, constant. It's quadratic form.
Oh, so when something in quadratic form, you
Group it, yeah.
Group that.
Okay? All right.
Group that.
What can you take out first two?
X squared.
What's left?
X squared.
Ooh, I see something happening. Middle sign. What can you take out the second two? What's left? How does that factor?
Is that the difference of 2 squared?
It is going to be a difference of 2 squares. All right, I've got 4x times. Here's my common. Now remember, to solve, I want to make sure it is factored completely. It's not. I see not 1, but 2 difference of 2 squares. Isn't this fun? I told you chapter 1 was just going to keep coming back and back and back. Just wait till you see what I show you next. I'm so excited. Okay,
About the RK, x squared.
what do you do? How's it factor?
X and 1.
Bella's gonna be so lost when she comes back. She's gonna watch the
Imagine Miss Wilson teaches this lesson. She'd be like jumping up.
Hey Bella, only Shaggy would know how to do something like this.
All right. Now everybody goes to 0.
Why is it
4x. It's that. All right, let me stop. Yes, if you want the notes when you solve, you want to make it equal 0.
This is going to be a long chapter.
Factor completely. It all ties in though. The nice thing about this chapter is that when we get to the end, we'll use everything to do the very last section. It'll take factoring, special patterns, properties, it'll take everything we learned to be able to do the very last.
Mathematics
Just to find the answer.
Yeah.
Just make sure the homework.
Who needs you math? You cannot.
All right, several of you asked, guys, several of you asked about why we do this. This is to find all the solutions And so this one had 1, 2, 3, 4, 5 solutions, which not coincidentally.
To the fifth.
Good job! Oh my gosh, you're the first person I've ever had make that connection. That is the fundamental theorem of algebra.
Wait, what did you just say?
I thought.
I didn't understand.
How many solutions did we have? 5. What was the biggest exponent we started with? Coincidence? I think not.
Gosh.
Wait, what?
Math is
X
what you
equals plus or
do.
minus 1.
All right, take a look at this polynomial. Pretty nasty polynomial, right?
Zero.
I need to solve it for x. So yes, you're right. I need to make it equal 0. So my question is, where do I move everything?
I like to make my biggest one positive.
That's exactly right. Keep the big. That's right. Keep the biggest exponent positive. It's going to make your factoring life easier. So to do that, 4 is my biggest. I'm going to add that to both sides. Now, some of you asked yesterday about order. Does order matter? And when you're adding or subtracting, I mean, it doesn't really matter, but technically standard form is biggest exponent down to smallest, okay? So what I want to do is keep this in standard form, so it would be 6x to the 4th minus 27x cubed plus 15x squared equals 0.
15x squared.
Okay, take out 3. I hear a lot of you saying 3. I'm going to take 3x squared out. What's left?
2x squared minus 9x plus 5.
Equals,
Good job, Ella.
is it factored completely?
No.
Well, I don't know yet. 2 times 5 is
10.
what multiplies to 10 but adds to negative 9. Ooh, no.
Oh my gosh.
That does not multiply to positive 10. It must multiply to positive but add to negative 9. I don't think it does either. Oh my gosh. Okay, so let's think this through. Once it's factored completely, we set each piece to 0, right?
Do we have to like subtract the 5 like we did for the last one?
I want you to think.
How is it factored complete?
Because that's a CBF that y'all loved so much in chapter 1, but when we get to chapter 2, CBFs are no bueno.
Not gonna lie, like anything that I couldn't find out, I'd be looking up.
CBF, yes, I know. So now welcome to the world of CBF where it's not as fun anymore.
We have to.
How in the heck? Oh, there's 2 X's. There's more than one X. Can't sat map it, but I like your thinking. You're thinking along the right lines. Continue.
Technically, I wasn't wrong.
Can we just subtract
Should I
5
subtract
and set it equal to 5?
Okay, so if we subtract 5, where's that going to take us? It's going to take us to 2x squared minus 9x equals negative 5.
But then you do the thing where you
Perfect square? What perfect square?
b divided by 2 times b divided by 2.
Okay, yes, you could do that, but oh my gosh, we'd have to divide everything by the leading coefficient, which is 2, which would give me a factor. I'd be completing the square with a number. Guys, come on!
Oh my gosh.
I got it.
See? Do we need to get it? That's what I said.
That's what I said.
What, Joseph, what?
Get an easy point. I don't know. CBM.
So we're gonna do the quadratic formula?
Yes.
No, we're doing the quadratic formula. Is it too late to get out of class?
I was trying to be like, I was trying to get it done, but y'all saw what I was pulling up. I couldn't get it done in time. This, by the way, is a repeated solution.
That was what I was literally
So
trying
X
to say, and
is a-
everybody was screaming over me and made me lose it. So.
I mean, y'all are not wrong. Y'all are not wrong to try to find a good C and complete the square. It's just, it's hard whenever it's like, because you're going to have 9 over 2 in the middle. Half of 9 over 2 squared. It's going to be like 81 over 16. That's going to be,
From now on, is like CBF unacceptable and we have to just do
Yes.
quadratic formula?
if you're solving, yes.
Opposite B plus or minus square root.
Keep going.
B squared minus 4AC
All
over 2A quadratic formula.
Sorry.
Or turn me up, boy.
81 minus 40 would be 41. Y'all cannot tell me that that was harder than completing the square with that.
I don't even know what to think right
that was
now.
the answer.
I'm so discombobulated.
Because 41 does not factor down, it's just not in the video. We were doing the cube that's a pattern. Anytime you have a cube, like if I had x cubed minus 27, that's a difference of two cubes, right?
So after you factor it, you can just do whatever you really like that. Like whatever.
You have to factor it completely and then you set each piece to 0. So like for this one, when you factor this, little parenthesis, big parenthesis, it still equals 0, right? Same, change, plus. What goes here? 7, 3. What goes in the first one?
X squared. 9.
I do it backwards just because I use first, last. So what I'm telling you is when you do this, Wills, this one is always a CBF, which means this one's always going to be x minus 3 equals 0, x equals 3. But this one is always going to be either a complete the square or a quadratic formula every time.
Nope, never mind.
It won't factor.
I got you.
So it's going to be opposite b plus or minus square root b squared, so 9 minus 4 times 1 times 9 over 2h. Guys, I know y'all are excited about this, but stay with me.
So when it can't.
It's 36. Negative 27.
Over 2x.
But this is the one I was telling you.
It's I times the square root of 27.
It is I, but it's actually 3i times the square root of 3. You will not write? Why?
So discombobulated.
You love that word, don't you? I don't even know it's just.
I asked him how to spell it.
He's Confucian.
All right, so at this point, if there was a factor of 3 down here in the bottom where the 2 is, I could then divide everything by 3. I know this was a loaded lesson for a Friday. Y'all have been quite...